managed to speak the last because all important points have already been made, most of them. That's true, actually. I really enjoyed the meeting and the content that we discussed today. So I'll try to highlight some of the aspects that have been less emphasized and give my perspectives on that. So I'm going to improvise a little bit, so bear with me according to the slides. Yes, so indeed, as Haksu mentioned, so I was in the fairness-aware machine learning field from the very beginning. We started in around 2008 or 2009, and in fact, we got to define the field as it was then. We were about 5 people back then, handful really, then maybe 10 worldwide, thinking about these issues. And I'm very happy to see some of the concepts that we thought about making into the classical frameworks nowadays being presented as, well, state-of-the-art. That was the situation. We started with fairness-aware machine learning as a technical challenge, but very quickly we ran into realization that, as we talk about today, that it's a societal aspect. That, again, as it was mentioned many times today, solving technological challenges alone will not solve fairness. And again, quoting Blaise today, that studying how to make fair decisions, we will have people to make better decisions in the society as well. So yeah, that's a big challenge and big interdisciplinary challenge, and it's very nice to see what the field has become today with so many interdisciplinary great minds thinking about it. We also saw a trend of machine learning, fairness-aware machine learning papers coming out since 2010s exploding. And we saw one now that around 2013-14 it seemed to be solved. No, it didn't seem to be solved. It actually seemed hopeless around 2013 until revival or resurrection of the whole field around 2015 when I think when Obama's report came, 90 days big data review, pointed out that yeah, technologies can help, but technology can also discriminate and can also do harm in the society. And since then, much more resources and thoughts have been put into, and we are here where we are today. So yes, data science. I want to reiterate again the point that was made today, that there is no one eye and there is no one perspective thinking about AI. It's all context dependent and it's all circumstances dependent, and we have to look into fairness, ethics, transparency and accountability in a situation dependent way. I want to run through this example that I prepared, and many of you probably have heard about Boeing Max case recently, several crashes, where essentially, it's not strictly speaking, the system probably is not an AI, it's a rule-based system helping to pilot the plane. So the way it went was that when Boeing redesigned the plane, they put larger engines on essentially the same body of the plane. And not to have to redesign too much, what they did is they did software correction instead. So they made a software solution that would correct for imbalance of the plane due to well, I'm simplifying, but due to two larger engines. Essentially, not in all circumstances and not all airlines put effort to retrain pilots and make aware of what the system actually does. And well, as it's seen now, what happened when these crashes happened is that system and pilots kept overriding each other's decisions and correcting the plane until, well, twice they crashed. So, so the point here is, I want to make here 2 points. So one is that system behavior is subject to also to assumptions of humans, so assumptions of pilots of how they think the system behaves. So it's not, there is no one right way of making the system or making behavior, but they have to be made in the context of what people think about, users think about it, and users have to be retrained accordingly. Another important point that I want to make with this slide is transparency. So transparency here is at the same time lack of transparency and also a lot of transparency that we get here. With human decision makers, when medical doctors, judges, or banking authorities make decisions, we cannot really go back and see what happened in authorities' head, in human head when decision was made. We can request for explanations, but we will never know how the decision was really made. With AI and with technological systems, what we have the luxury of going back and essentially replaying the tape. So in some ways, it's less transparent and we don't really understand how it works, but in many ways, it's also more transparent because now we can really look into and play back and understand how the systems work. So it's good news, I think. Software drives, I put the title that software drives plane, can software also drive science? I wanted to make a point about objectivity here, which was also briefly mentioned during our discussions. Society often thinks that what comes from technology is inherently objective. Scientists wish to outsource, not only scientists, but many domains wish to outsource interpretations to artificial intelligence. An important distinction that has to be made and emphasized is that objectivity is not the same as consistency. Technological systems, AI systems, are most of the times consistent. I mean, they can be non-deterministic, but they would make the same decision again for in the same circumstances and for the same person. It does not mean that it's objective, and objectivity as a notion as such, we have to define it. There is no one single way of making objective decisions. And since AI systems, they cannot replicate the world as it is, they always make summaries and generalizations. So in which way the summary is made, is which information is left out, is a matter of, well, subjective objectivity, if we will. So so an important point to emphasize is that yes, that consistency is not the same as objectivity, but consistency is also good to have. It's the same as the point with transparency. So we can come back and we can replay the tape and we can check if what we are doing with technology, if we are doing with AI systems, is consistent with, if we are doing with technology is in line with how we want objectivity to be. I'll skip that. Yes, so there were mentions strong AI versus weak AI and clear understanding that current AI systems are specialized towards narrow tasks, so they are weak AI in a way. I want to make 2 points here about what AI can do in human decision making, in what circumstances AI can help human decision making. So there are 2 situations basically. To help with decisions that humans can do themselves, but make it more efficiently, or cheaper, if we will. So that would be, for instance, recognizing cats from dogs in the pictures in a toy example. So that's a task that humans can do, machines can replicate and do it more efficiently, cheaper, or in other way. But the other type where AI can be used is tasks where what humans cannot do. For example, multiplying 2 7-digit numbers does not require AI. It's very simple for computers. Humans cannot do. And in that case, if humans cannot do that, they cannot verify that. So we cannot rely that there will be always post hoc somebody checking, okay, can we trust, can we audit, can we certify what decision computer has made. So humans can only post hoc check, certify if they can do the tasks themselves. And these 2 types of tasks, actually there is an interesting evolutionary discourse that I want to briefly make. Tasks that are easy for humans and difficult for computers, they are not actually easy tasks. For example, mechanical tasks like catching a ball, riding a bicycle, playing football are difficult for computers. For humans, they are easy because they are hardwired in us, in the evolutionary process. Because, like historically, let's say if if a tiger is coming, we have to run. So we run, that saves our lives, that leads to reproduction and so on, evolutionary so on. Now, if tiger is coming, multiplying two seven-digit numbers very fast will still not save us from the tiger. So, the tasks that are easy for us as humans, they are sort of embedded into us to solve them. That's why they are seemingly easy. And those we can verify. So computer, as it was again already mentioned by Blaise today, that we can think them as external mind, if we will. So we should not think of external mind, that we just use it. I mean, we can use it as external mind, but we cannot hope to ever always be able to come back and verify whether it's right or wrong what the computer has done. So then that leads me to the question of what's written on our conference bags today. Can we trust AI? And I think, yes, we can, and we have no other choice but to trust AI if we want to use it in the circumstances as an external sort of thinking tool. Can we trust it in the decision makings that we can do ourselves in the circumstances in, say, instead of medical doctors, judges, personal decision making? There it comes, it's a matter of whether we want to outsource those decisions or not, and to what extent. Right, so I have more, but I think that I will rush through quickly to leave some time for discussion, but my slide doesn't change. Yes, and more. And I skip that. Yes, so why, once we trust AI, we still need to think and be aware of where things and what could be potential causes where things can go wrong. And as we heard many times today, it's circumstantial, it's context dependent, so there is no one way. The general principles in relation to fairness of our machine learning is things may go wrong often because we work on associative models, not causal models. And they go wrong because our associative models are trained on data that has biased decisions recorded from the past that was already mentioned. Data may be incomplete. I will not go into this example. Sampling procedure may be skewed. This is an airport screening example where selected people would be targeted for screening. So anyways, data collected in a special way. But also that one of the most important aspects is that society itself is changing. So the world is changing over time and data is never stationary. And once we work with associative models, not causal models, so changes in the society would immediately render our models in some way obsolete because the society is no longer the same as the historical data on which we are training our models. So then again, many times mentioned that it's not only technological challenge, but it's interdisciplinary challenge. There are no right or wrong variables, there is no right or wrong data. We have to define it in a context-dependent way. So at the end of the day, there is no raw data is an oxymoron. There is no such thing as raw data. And I think as fairness in machine learning as well as fairness in the society as a trade-off, as a zero-sum game in a way. And that's because our world has limited resources. So there is there will never be infinite amount of resources, whatever we're speaking of, either loans or social security benefits or any commercial energy for that matter. So resources are limited, and then it's always about redistribution. And if someone, as we saw in the illustrations, if someone gets more, someone gets less. So then it's always about trade-offs, and how these trade-offs would need to be made is a question of societal perspective. And then, of course, once from the societal perspective, we are decided what the fair distribution should be. Then there is a question of translators between societal values and technology. So the role of translators will be important, more and more important in the coming years. Those translators that can take verbal concepts and translate it into mathematical constraints that can then be embedded in algorithmic decision making. That's all. Thank you.